primarily testing is just our implicit differentiation. Uh, what we need to do is just show that the derivative is this. So they want to see all your work. So we need to do implicit differentiation on this curve. Oh, oops, messed up already. There we go. And I want to take my time because if you look on the last video that I made, there's an error. So just be careful and look in the comment, look in the info for the last video for number 7. Now, so how do I use implicit differentiation? So I take the derivative of this with respect to x, right? I want to find dy dx. And I gotta just realize that this here is a product. This is x times y squared. The derivative of x with respect to x is just 1 times y squared plus the derivative of y squared with respect to x is 2y dy dx by chain rule, right? It's the 2 comes down times y to the first and then multiply by the derivative of y times x minus the derivative of 2x cubed is going to be 6x squared equals the derivative of 2 is just 0. And now your first task is just to solve for dy dx here. So take your time, make sure you do this algebra correct. I'm going to move over everything that's not, every term that doesn't have dy dx in it, I'm going to move over. So I moved over the y squared term and then the negative 6x squared term. Then I'm going to divide by 2xy. And what I'm going to be left with is the dy dx. And that's just algebra. And I have shown that dy dx is indeed this equation they have. Now it says write an equation for the line tangent to the curve at the point 1, 2. This is as simple as knowing that this dy dx gives the slope of the tangent line. So here you evaluate dy dx. It's sometimes written sometimes written I think like this with a line and then 1, 2 here. And it's trying to say like you're evaluating what 1, 2 is, what the slope of the tangent line is. So 1 squared is 1 times 6 is just 6 minus 2 squared is 4 over 2 times 1 times 2 is 4. I'm going to get 6 minus 4 is 2 over 4. I'm going to get 1/2. Just going to do that again because I made a mistake in the last video and I don't want to make a mistake in this one. 6 minus 4 over 2 times 2. 2 times 1 times 2. Yeah, it is definitely 1/2. Okay, good. Alright, so now I have that the slope is 1/2. And I have a point. It's up to you how you do this. I'll write it y equals 1/2 x plus b, where b we don't know yet. But you could use the fact that this is a point on your curve, or on your line, I should say, on your line. 1/2 times 1 plus b. Right? I plugged in 2 for y and 1 for x, and then that allows me to solve for b. B is going to be 1 1/2, or 3 over 2. And then y equals 1/2 x plus 3 over 2. And then that's part B. So A I did, B now, and now C. So now let's see C. Find the x-coordinate of the point. Find the x-coordinate of the point P at which the line tangent to the curve at P is horizontal. Okay, so you want to find the x-coordinate of the point P at which the line tangent to the curve is horizontal. Okay, at P is horizontal. You want to find out when it is that this derivative is 0. Okay, so you need to know when is it that 6x squared minus y squared equals 0, because that's going to enable you to figuring out what you have here. Because if this top part is 0, then you know you're done. You're good from there. But now the trick is seeing, what do we have? Find the x coordinate of the point P at which the line tangent to the curve at P is horizontal. So any 2 points satisfying this and then the original equation should work. So what you need to do is you need to solve this. 6x squared equals y squared. And then if you look back in your original equation, it has to satisfy both equations. It has to be that it makes the derivative 0. That guarantees that the line tangent to the curve at P is horizontal. That's this equation. But now it needs to satisfy this equation because it needs to be on the curve. So I'm making this equation true and I get this relation. I get 6x squared has to equal y squared. And then now I'm rewriting for y squared. X times 6x squared minus 2x cubed equals 2. And then I'm going to get 6x cubed minus 2x cubed equals 2. And then this becomes 4x cubed is equal to 2. I get x cubed is equal to 1/2. And then that means that x is equal to the cube root of 1/2. Did I do everything? Okay, yeah, 4 is going to be 1/2. Okay, find the value of dy dx at the point. Okay, so you just have to differentiate again. And you already plugged in for what 1, 2, what kind of value that is. It's 1/2. So when I take the second derivative, I'm going to do d, and that's going to be the derivative of the derivative, which is this right here. And you're going to have to use quotient rule. This is going to be a pain. So it's the derivative of the top, which is 12x minus 2y dy dx times the bottom, 2xy, minus the derivative of the bottom, you have to do product rule. 2xy, the derivative of 2x is just 2 times y, plus the derivative of y is dy dx times 2x. And that goes right here. You're going to get 2y plus 2x dy dx times the top. So I'm going to try and move this. Oh, no, not what I want to do. Okay. And then I have, okay, times the bottom 6 times the top 6x squared minus y squared all over the bottom squared. So 4x squared y squared. And now I want to evaluate this at 1, 2. So again, take your time with this. So let's see what we get. So evaluating that at 1, 2, I'm going to get 12 minus 4 times. I already know what dy dx is evaluated at 1, 2. It's 1/2. So it's 4 times 1/2 is going to give me just minus 2 here. So it's 12 minus 2 times 2 times 1 times 2 is 4 minus 2 times 2 is 4 plus 2 times 1 times 1/2 is 1. I'm going to do that again to make sure. 2 times 2 is the 4 plus 2 times 1 is 2 and then times 1/2 because I know that this evaluated at 1, 2 is just 1/2. So it's 1 the whole thing times 1 squared is 1, 6 minus 4 is just 2 over 4 times 4 is 16. Okay, this is 12 minus 2, it's 10, it's 40, minus 5 times 2 is 10 over 16. 30 over 16 is equal to 15 over 8. Alright, take your time with these calculations, especially this last two over here.